Hello, you are welcome to the third part of this tutorial. So before we proceed solving any questions, I want us to quickly take a look at logical operators and then conditional statements. So I'm going to list the logical operators that we have. We have the equal to, we have not equal to, we have the less than, greater than, we have less or equal to, we have greater or equal to, and we have the or and the end. Okay, so let's see how we use each of these. Okay, so let's write a little program. I'm going to declare a variable called p, and then I'm going to assign it 5 and declare kill and assign it 6. So I'm going to say if p is exactly equal to 5, then we come inside and write another condition. So if kill greater or equal to 5, and then we display something. So it's true. Let's say it's true. Let's end the first if and the second if. So this is what we call the nested if statement. Okay, so we have the first if, and inside that one we also have another if. Okay, so for this if inside here to be executed, the first one is supposed to be true before this one can be executed. And then looking at our code, you can see p is exactly equal to 5, so this one will pass, and then we come inside this one to execute this one, and we see also kill is greater or equal to, is greater than 5 actually, so this line of code here will be executed. So let's run the code and then let's see what we get. So we get is true, but this same statement here can easily be written in one line of code using the AND operator. Okay, the AND logical operator. So let's see how this is done. We say if p is exactly equal to 5 and kill is greater or equal to 5, display it's true. Okay, and let's end it. Okay, so you can see that this line of code here, this lines of code here can be written the same way as this. Okay, so this is what the AND operator is used for. So we all know that we can also use the AND operator when it is only one, but however MATLAB is recommending that we use the double operator. Okay, so when you see that one, it means the same as the AND. Okay, so let's run the code and see what we get. So we get is true 2 times right here. So the first one is from this program, and then the second one is from this program. So before this thing can be executed, it means both of this must be what's true. So that's what the AND operator checks for. So let's intentionally declare another variable. Let's say v is equal to 3 and z is equal to 2, and let's use the or logical operator. So we say if v is less than 1 or z is greater than 1. Okay, so then let's display one of them or all was true. Let's end the if. So using the logical operator or, only one of the statements must be true for this one to come to pass, or the code, the line of code to be executed. Okay, so the first statement checking v less than 1 is false, and then checking z greater than 1 is true. So since one of it is true, then it means that this line of code here is going to be executed. So let's run the code and then see the answer we get. So we run it and then we get one of them or all was true. So it means this line of code was not executed. Okay, so that's what the or operator also does. So equally you can use the greater than, less or equal to, and then less than to compare stuff or compare variables or numbers. We can also use the not equal to, okay, to compare. So this is the not equal to. So when you see this is the not equal to. Okay, so for us to understand the nested for loop, I'm going to write a program. So I'm going to say for I equals, and please, if you don't know the loops, you can check out my videos. I've done a video on all of this. For I equals 1 to 3, and then inside this loop we have another 4. So for j equals, okay, and one thing is when you are writing nested for loops, you do not use the same variable. Okay, so the convention is ij, and then if you have a third for loop, you use k. So for j equals 1 to 2, and then let's display I times j, and then end the first for loop and end the second for loop. So the beautiful thing about nested for loop is that the inner loop has to complete its cycle before this variable here changes. Okay, so when we run this, what is going to happen is that when I is equal to 1, now it will step into the body of the code here, and then j is going to also start from 1, print this one, and then go over, print this one. Since I is starting from 1 to 2, it is going to complete a cycle in 2 runs, and then when it is done, it moves back to the outer loop and then increment I to be equal to 2, and then it comes back to this lines of code here and then repeat the inner loop. Okay, and then it goes back after the inner loop is done, it goes back to the main loop again, and then it also comes inside and then repeats this loop again. So in all, this loop is going to run 3 times since it's inside the main for loop or the outer for loop. Okay, so to be able to understand this, I'm going to use Flogorithm to graphically help us understand this one. So this is the program. I have declared I and j, and then I have the outer loop running from I equals 1 to 3, and then the inner loop, which is j, running from 1 to 2. So let's run this program step by step and then see how this program works. So when I start the program, I initialize, and then it gets the first for loop. So when you go on, it's going to step into the smaller for loop, and watch what happens. So it goes 1, print out the output, which is here, and then it comes back to the smaller for loop again. Since it has not completed the cycle, it's supposed to be twice. And so we do that, and then its cycle is complete. So when the cycle is complete, it moves to the main for loop again, and then it comes back into it, does its cycle, so which is twice, and then when it's done with its cycle, it moves back into the main loop, and then so that one is also going to come back the 3rd time and then do its cycle again, and when that one is done, it goes back and then the program ends. So this is how the nested for loop works. When the outer loop runs, the inside one has to complete a cycle before the code returns to the outer loop. Okay, so let's run this code and then see what you get. So I'm going to run it, and then the answer is going to be what, 6. So another thing I want to talk about is the for loop can have another parameter. So let's say for I equals 1, then we can have the second parameter like 2, and then to 10. What this means is that we are starting from 1, so for I equals 1 in steps of 2 to 10. Okay, so it means that first time I is going to be 1, and then it will add 2 to it, which is going to be 3, 2 to it, which is going to be 5, 2 to it to be 7, and then 2 to it to be 9. This is another type where we have steps, not moving in ones but 2. So whenever you see the middle parameter, it stands for the steps you are moving. Okay, so you can have this and then have for j equals 1 to 2, then display I times j, and then let's end it and end this one too. So let's run the code and see what we get. So we get 18 as our final answer. Moving from here, let's quickly solve some examples. So we have our first question here, having r to be equal to 0, and then we have a for loop for y equals 1, and then moving in steps of 1 to 6. So what we are doing here is at every point in time we add 3 to r. Okay, so this means that at the first time we are going to have r to be 0, and then when I is equal to 1, we get r to be equal to 3, The second time you're going to get r to be 6, third time r to be 9, fourth time r to be 12, fifth 15, and then when it is 6 we get 18. So when we run this code, the value of r should be what? 18. So this is how to cater for such situations. Okay, so let me just clear this one. So when we display r, we get 18 as our answer. Now moving to the next question, we have a while loop where I is equal to 0, and then while I is less or equal to 10, I is equal to I plus 1. So the I equals I plus 1 is just the increment for the while loop, and it doesn't mean anything so special here. So it's just catering for the fact that I has to increase to keep the loop moving. And then what we are looking for is A. So looking at this loop, there's no need to even work for it, because the only thing we are doing is that we are assigning the value of what? I to A. So it means that this loop is going to run from what? 0 up to 10, and this is 11 times. Okay, so when we run this code, we should get 11 as our answer. So it means it's going to run when I is equal to 0, add 1 to it when I is equal to 1, and it will move that way up to when I is equal to 10. So that gives us 11 elements. So I will be equal to 11 on the last run. So it means A will also be assigned what? 11. So let's put this program into our MATLAB and then see what we get. When we run it, we get 11 as our answer. Okay, so as expected. Okay, so moving to the next question, we have this one here, and then this is almost the same as the first one, and then I trust you can be able to cater for this one. Now let's see something more interesting. So we have this question here. We have been given a vector, and then we have n equals the length of y minus 1. So what's the length of this vector? We have 5 elements in this vector, so 1 3 4 5, and then the length of this vector is going to return 5, minus 1 is going to be 4. So that means that n is going to be assigned what? 4. Okay, and we have a loop. So what I guess you've not seen before is this si right here. Okay, so no vector has been defined as s, but we have si. So let's quickly take a look at that one, and let's continue the program. Okay, so what this means is that when you create a variable like this, and then you say 10, for example, then you assign it 5. What this means is that you have created a vector, okay, so filled with zeros, except the last index, which is going to be 10, will be equal to 5. So this is what this particular definition is. So let's display x and then see what we have. So when we display x, we see that everything here is equal to 0. So this is a vector except the last index which you assigned. So it's just a definition. Okay, so let's move on to the main question. So from the question, we have si to be equal to yi plus 1. Okay, so what this means is that at every index, so let's say s4 is equal to y, so we are picking the element from the y vector. Okay, so there's no need summing, because we are not actually summing or storing the sum of anything. So what we are going to have is s4. So now when I is equal to 4, we are going to have s4 to be equal to y4 plus y5. Okay, so y4 is 8 and then y5 is 9. So because of this, we are going to get what? 17 as our answer. Okay, so let's move to the next question. Now we have this. So as we all know, or even if you don't know, we have the inline function. So the inline function is used to define your own function. Okay, you can use it to define your own function. So when we write this code, we have j is equal to inline, then x minus 5. So which means that this function, it will just take in any value you give to it and then subtract 5 from it. And then we have x1, which is also a definition. So we are saying we are creating a variable x, and then at the first index we are assigning it 0, and then we have a for loop for I equals 1 in steps of 1 to 4, and then t equals j xi. Okay, so we are passing x and then the index. So let's quickly observe how this code is going to be processed. So in the first run, it has already been defined that x1 is equal to 0. Okay, so when I is equal to 1, we have x1, and then we know that x1 is equal to 0. So that means we are passing 0 into the function. So when we pass 0 into the function, 0 minus 5 is going to give us negative 5. So which means t is going to be what? Negative 5 on the first run. And then by the definition, we are just incrementing, or we are redefining the x. So we say xi plus 1, which is going to be 2. So we are defining x2. So x2 is going to be xi, which is what? The 0 plus 1. So it means x2 is going to be what? 1. So it means at every run you keep adding 1 to these values. Okay, when you have I equals 3, you are now going to have t to be equal to what? Negative 3, and then x4 is going to be what? 3. And then when I is equal to 4, finally you pass in this 3 into the function, inline function, and then you are going to get what? Negative 2 as the answer back. So this is how to also process this type of code. So let's just run it in MATLAB and then see if our answer is right. Okay, so let's run and see what we get. So we get negative 2. Okay, so this is how to also process this kind of code. So moving to our next question, we have a program and we have n is equal to input, enter the value of n. We have x is equal to zeros, 2n minus 1, and then n. Okay, so we know the zeros function. We have if modulus of n and 2, n modulus 2 is equal to 0, then we have a for loop. Otherwise, we have another for loop. So what will be the output of this program when n is equal to 1? So let's quickly take a critical look at this, and then so we enter 1 into the program. We will have 2 times n here, which is 2. That's 2 and 2 minus 1, which will be 1, and we know n is 1. So we are going to have zeros 1 1, and zeros 1 1 will return a 1 by 1 dimension. It's the same as 1 by 1 dimension of 0. So this means that x will be equal to 0 from this place. And then after that we come to this place, so we check if the modulus of n, we know n is 1, so 1 modulus 2 is equal to what? 1. So because of this statement is false, so this 1 will never be executed, so the else will be executed. We now have to calculate and then find the solution to this question. So we have x and then n minus into brackets I minus 1 colon n plus 1 I minus 1, and we have n minus 1 plus 1. So let's quickly digest this and then let's see how we can put it together. So x of n minus 1, n minus I minus, so at this instance I is equal to 1, and so if I is equal to 1, we have 1 minus 1, which is 0, and then n is equal to 1, so which means we have 1 here. So we are going to get x of 1 and then colon, and then we have I minus 1 again, which is 0, so and we get n again, so 1. So that will be for the row, and then for the column we have n minus 1 plus 1. So n minus 1 will be 0, plus 1 will be 1. So we'll have this. So the vector 1 is to 1 is the same as 1. So in all we have x 1 1. So this is what we are going to get. And from here we are assigning x 1 1. So we are assigning the first index of x to I, and I is equal to 1. So because of this, x will assume 1 as its final value. Okay, so x after this program runs should be 1 if we enter the value 1. So let's run the program and then enter 1 and then see how the program will run. So we didn't display the value of x, so let's display that of x. So let's run it again. We have 1, and so we get 1 as the final answer. So if you enjoyed the video, please consider subscribing to the channel and then liking the videos as well, and don't forget to share with your friends. Thanks for watching.